There is a sound that no one ever hears, yet every astronaut knows by heart. It is the sound of a mechanical latch clicking open in a vacuum. It is a dry, metallic snap that vibrates through the bones of your suit, bypassing the silence of the void. On the morning of February 7th, 1984, that click changed the world. Imagine you are standing in the cargo bay of the Space Shuttle Challenger. You are 170 miles above the surface of the Earth. Beneath your boots, the world is moving at 17,500 miles per hour, a blurring tapestry of sapphire oceans and swirling white clouds. You are traveling at 5 miles every single second, but here, in the stillness, you feel motionless. You are a ghost in a machine. For 25 years, NASA had a rule, a law written in the blood of the pioneers. You do not leave the ship without a tether. You are always connected. You are a kite on a string, a diver on an umbilical cord. The ship is life. The ship is oxygen. The ship is the only thing standing between you and a cold, infinite grave. But Bruce McCandless is about to break that law. He is strapped into a machine that looks like a high-tech office chair from a nightmare. It's called the MMU, the Manned Maneuvering Unit. It is a bulky, white throne of nitrogen tanks and thruster jets. Bruce reaches out with his gloved hands, his fingers thick and clumsy in the pressurized layers of his suit, and he toggles the controls on the armrests. The latches release. For a heartbeat, nothing happens. Bruce is still there, floating in the bay. Then, with a gentle puff of nitrogen gas, invisible in the vacuum, he begins to move, slowly, an inch, a foot, a yard. He is moving away from the Challenger. He is moving away from the only island of safety in a black ocean. Inside the shuttle, his fellow astronauts are watching through the windows, their breath held, cameras clicking. They are watching a man voluntarily become a satellite. Bruce doesn't look back. He can't see the ship anymore. He can only see the horizon of the Earth and the terrifying, beautiful deep of the universe. In the ears of the world, there is a long, heavy silence. And then, the voice of Bruce McCandless crackles over the radio. He isn't screaming. He isn't panicking. His voice is calm, almost academic. He has the steady tone of a man who has spent 20 years calculating the math of this moment. It may have been one small step for Neil, Bruce says, a slight grin audible in his words, but it's a heck of a big leap for me. This is the story of that leap. This is the story of the man who decided that a tether was a cage, and that to truly be a child of the stars, he had to let go of the hand of Mother Earth. This is the story of the MMU, the nitrogen chair, and the quiet engineer who spent his entire life preparing for the loneliest walk in history. To understand why a man would do this, you have to understand the era. 1984, the space shuttle was supposed to be the space truck. It was the dawn of a new age where humans wouldn't just visit orbit. We would work there. We were going to build space stations. We were going to catch broken satellites with our bare hands. But to do that, we needed to be free. We couldn't be tangled in hoses and wires. NASA wanted a superhero. They wanted a person who could fly through the void like a bird, governed only by the flick of a wrist. The MMU was the answer. It was the most complex personal flight system ever devised. It carried 24 small nozzles. When Bruce pushed the joystick forward, nitrogen gas hissed out of the back. When he twisted his wrist, he spun. It was a ballet of physics. It was Newton's third law in its purest, most dangerous form. But Bruce McCandless wasn't a daredevil. He wasn't a right-stuff hotshot looking for glory. He was the most unlikely person to become an icon of freedom. Bruce was an engineer's engineer. He was a man of checklists and redundancies. He was a man who knew the name of every bolt and the pressure of every valve in the shuttle. He had waited a long time for this. Bruce was part of the original 19. The group of astronauts selected in 1966. You watched his friends go to the moon. He sat in mission control as the capsule communicator for Apollo 11. It was Bruce's voice that Neil Armstrong heard when he first stepped onto the lunar dust. Bruce was the one who told Neil and Buzz that they were clear for T2 on the moon. For nearly 2 decades, Bruce remained in the shadows. He didn't get the ticker tape parades. He didn't get his face on the cover of Time magazine. He stayed behind, working in the labs, helping to design the very suits and the very tools that others would use. He spent years in the neutral buoyancy lab, the giant swimming pools where astronauts practice for space. He spent thousands of hours underwater, wearing hundreds of pounds of lead and fabric, perfecting the movement of the MMU. He knew the machine better than anyone because he helped build it. By the time he was assigned to mission STS-41B on the Challenger, Bruce was 46 years old. He was a veteran who had never flown. He was a man who had seen the glory of others and had remained content to be the foundation they stood upon. But on that February morning, the foundation was gone. As he drifted further from the shuttle, a profound psychological shift began to occur. When you are tethered to a ship, you are a part of that ship. You are an extension of its hull. Your mind perceives the ship as home. But once the tether is gone, your brain has to solve a terrifying equation. Where am I? Bruce was now his own spacecraft. He had his own propulsion. He had his own life support. He had his own navigation. For the first time in human history, a person was not on something. He was just there. He was traveling at 17,000 miles per hour, but the wind didn't whistle past his ears. There is no air to move. He felt no sensation of speed. He only felt the sensation of falling, forever. If his thrusters failed now, he wouldn't fall back to Earth immediately. He would stay in orbit. He would become a permanent, frozen moon of the planet. He would circle the globe every 90 minutes, a silent monument to human curiosity, until his oxygen ran out and his body was reclaimed by the friction of the upper atmosphere months later. The Challenger looked smaller now. It was no longer a massive fortress. It was a toy, a white shape against the infinite black. In the cargo bay, the other astronauts were silent. They knew the risks. If Bruce drifted too far, or if he entered a spin he couldn't control, there was very little they could do. The shuttle wasn't designed to chase a single person. It was a heavy, clumsy vehicle in orbit. To fire the main engines to save Bruce might incinerate him in the blast. Bruce was on his own. He looked down at his feet. Between his boots, there was nothing but 200 miles of empty space, and then the coast of Florida. He could see the Cape. He could see the place where he had launched just days before. He felt a strange sense of calm. The suit was pressurized to about 4.3 pounds per square inch. It was stiff, like being inside a balloon. Every movement took effort, but the MMU responded to his touch with a precision that felt like magic. The visibility is spectacular, Bruce radioed. He wasn't just talking about the view. He was talking about the clarity of the soul. When you are that alone, the noise of the world disappears. The politics, the Cold War, the stress of the mission, it all evaporates. There is only the hum of the fans in your backpack and the rhythmic, steady sound of your own heart. Bruce McCandless was a man who loved order, and here, in the most chaotic environment imaginable, he found a perfect mathematical peace. But this peace was expensive. It had been bought with years of failure and near disasters. Before we can follow Bruce further into the abyss, we have to look back. We have to look at the Wild West days of extravehicular activity, the EVA. In the 1960s, we didn't know how to move in space. We thought it would be easy. We thought you could just swim through the void. We were wrong. The first American to walk in space was Ed White in 1965. He loved it so much he didn't want to come back inside. But Ed White was lucky. He had a simple gas gun that ran out of fuel in minutes. He spent most of his time tangled in his tether, fighting the suit. Then came Gene Cernan on Gemini 9. Cernan's mission was to test a precursor to the MMU, the AMU, Astronaut Maneuvering Unit. It was a disaster. Cernan struggled to move in the stiff suit. He didn't have enough handholds on the outside of the Gemini capsule. His heart rate skyrocketed to 180 beats per minute. He was sweating so hard that his visor fogged up. He was blind, exhausted, and overheated, fighting for his life in the dark. NASA realized that moving in space wasn't a game. It was a battle against physics. They cancelled the AMU. They went back to the drawing board. They realized they needed a system that didn't require the pilot to fight the suit. They needed a system that was integrated, automated, and stable. Bruce McCandless was one of the people who sat in those meetings in the late 60s. He listened to the horror stories of Gene Cernan. He studied the data from the Skylab missions, where astronauts experimented with jet shoes and backpack units inside the massive empty volume of the station. Bruce knew that the secret wasn't power, it was control. The MMU that Bruce was wearing in 1984 was the result of those 20 years of hard-won lessons. It had redundant tanks. It had a gyroscope system that could automatically stabilize the pilot. If Bruce took his hands off the controls, the chair would fire its own thrusters to stop any drift. It was designed to be the safest way to do the most dangerous thing. But safe is a relative term when you are 150 miles high. As Bruce reached 60 feet from the shuttle, he decided to test the limits. He didn't just want to float, he wanted to fly. He pushed the left-hand controller. The MMU responded instantly. He began a slow, majestic roll. The Cardo Bay of the Challenger rotated out of his vision. Now there was only the black, the deep velvet black of the universe. In that moment, Bruce McCandless ceased to be an American. He ceased to be a father, a husband, or a NASA employee. He became a celestial body. He was a satellite of Earth. He had his own inclination. He had his own orbital velocity. He was a moon made of flesh and nitrogen. He was the smallest satellite in the world. And as he looked out into the void, he realized that he wasn't afraid. He felt a sense of belonging that few humans have ever experienced. He wasn't a stranger in space. He was a citizen of it. The light of the sun hit the gold-plated visor of his helmet, reflecting the curve of the Earth in a brilliant, blinding arc. To the people watching on Earth, Bruce was a tiny white speck, a star that had wandered too close to home. But Bruce didn't feel small. He felt enormous. He was 320 feet away from the ship now. The distance was so great that the Challenger looked like a lonely, fragile toy. I'm at the end of the line, Bruce thought. But there was no line. He was truly free. Bruce McCandless is now 320 feet away from the Space Shuttle Challenger. To the human eye, looking out through the triple-paned high-pressure windows of the flight deck, he has become a tiny white geometric shape, a lonely cross etched against the obsidian canvas of the universe. He is far enough away that he can no longer hear the faint, comforting vibrations of the shuttle's life support systems through his boots. He is far enough away that the Challenger is no longer a world. It is merely an object. At this distance, the physics of his situation become visceral. On Earth, we are defined by our tethers. Gravity is a tether. The air we breathe is a tether. The very floor beneath our feet is a tether. But out here, Bruce is experiencing a profound divorce from every physical certainty that has defined human evolution for 6 million years. He is no longer an inhabitant of a place. He is a participant in a vacuum. He is sitting in the MMU, the Manned Maneuvering Unit. It is more than a jetpack. It is a masterpiece of redundant engineering, born from the failures of the past and the cold, hard logic of the future. To look at it, The MMU resembles a large white backpack with two extended armrests, a throne of technology. It weighs over 340 pounds on Earth, a massive, clumsy weight of nickel-steel tanks, aluminum frames, and complex electronics. But here, in the microgravity of orbit, it is weightless. It is as light as a thought, yet it possesses the mass of a grand piano. Inside the two primary tanks of the MMU are 22 pounds of high-pressure nitrogen gas. Nitrogen was chosen because it is the ultimate conservative choice. It is stable, it is non-flammable, it doesn't create a plume of fire or a corrosive cloud that could melt an astronaut's suit, or coat the sensitive optics of the shuttle's cameras. It is a cold gas system. When Bruce toggles the joystick on his right armrest, a solenoid valve snaps open with a silent internal click. The nitrogen, compressed at 3,000 pounds per square inch, rushes out of a tiny, precision-machined nozzle. Action, reaction. Every puff of gas is a calculated movement in a world where friction does not exist to forgive your mistakes. There are 24 of these nozzles, arranged in clusters of 3. They are the muscles of the machine. They allow Bruce to move in 6 degrees of freedom. He can slide up, down, left, right, forward, and back. He can roll like a wheel, pitch like a diving bird, or yaw like a turning ship. But the real magic of the MMU isn't the propulsion, it is the stability. Bruce knew, better than anyone, the danger of the death spin. In the early days of spacewalks, during the Gemini program, astronauts struggled with momentum. If you push off a wall in space, you don't just move, you rotate. Your body isn't a perfect sphere. Your center of gravity is constantly shifting as you move your arms and legs. Without a stabilization system, a single puff of gas, if off-center by even a fraction of an inch, could send an astronaut into a tumble that would be impossible to stop. The MMU solved this with a sophisticated gyroscope system and an automatic attitude hold. If Bruce were hit by a stray force, or if he felt himself beginning to drift, he could simply let go of the controls. The internal computers, sensing the unwanted rotation, would fire counter-thrusters automatically, hiss by hiss, until he was brought to a dead stop in relation to the stars. It was the ultimate safety net, a digital hand that held him steady when there was no ground to stand on. It allowed the engineer in Bruce to override the animal fear of the void. Yet, as Bruce drifted further into the black, he was hyper-aware of the fragility of that digital hand. He was encased in a suit that was, in itself, a miracle of claustrophobic survival. The EMU, the extravehicular mobility unit, is not a garment. It is a one-person spacecraft that happens to be shaped like a human being. It consists of 14 layers of specialized material, each with a job to do. The inner layers are a mesh of plastic tubes, known as the LCVG, the liquid cooling and ventilation garment. Imagine wearing a second skin made of 300 feet of tiny, flexible pipes. Through these pipes, chilled water is constantly pumped, absorbing the heat of Bruce's body. In the vacuum of space, heat has nowhere to go. It cannot rise. It cannot blow away. Without this cooling system, Bruce would bake in his own body heat within minutes, even in the freezing darkness of the Earth's shadow. He could hear the water. It was a faint, rhythmic, whirring sound near his ears, the sound of the pump. It was the heartbeat of his suit, the mechanical proof that he was still alive. Then there were the layers of Dacron and Mylar, insulation designed to reflect the fierce, unshielded radiation of the sun. The outer layer was orthofabric, a tough white blend of Gore-Tex, Kevlar, and Nomex. It was designed to protect him from the sandblast of micrometeoroids. Every few seconds, a tiny grain of space dust, moving at 17,000 miles per hour, could potentially zip through the void. If one hit the suit, it wouldn't just be a scratch, it would be a kinetic explosion. A single grain could pierce the pressure bladder and Bruce would feel his life-giving atmosphere hiss away into the hungry dark. He could smell the suit. It was a sharp, clinical smell that never left him. It was a mix of recycled oxygen, the tang of ozone from the electronics, and the faint, metallic scent of the plastic water tubes. It was a smell that became his entire world, the olfactory signature of isolation. His vision was restricted by the helmet, a polycarbonate bubble with a gold-plated visor. The gold was there to filter the sun's infrared and ultraviolet rays, which would otherwise blind him or burn his retinas in seconds. Looking through that visor was like looking through a world of permanent amber twilight. It softened the harsh, jagged edges of the shadows in space, making the universe look more welcoming than it actually was. But the most overwhelming physical sensation was the pressure. The suit was pressurized to 4.3 pounds per square inch. This might sound low to a diver or a pilot, but in a vacuum it turned the suit into a rigid, inflated statue. Every time Bruce wanted to move his fingers, he had to fight the internal pressure of the glove. It was like trying to squeeze a very stiff, pressurized tennis ball over and over again for hours on end. His forearms were already burning with a dull, lactic ache. His fingertips were beginning to feel numb from the constant resistance. This was the dark reality of the untethered walk. It wasn't a graceful, effortless glide. It was a grueling physical labor performed inside a pressurized suit that fought his every movement. And then there was the fear. The fear at NASA wasn't that Bruce would simply float away because of a momentary lapse in judgment. The fear was a catastrophic technical failure that would leave him stranded. They called it the lost astronaut scenario. It was the stuff of nightmares in the astronaut office. If the MMU thrusters were to fail while Bruce was 300 feet away, he would be stuck. He would have no way to get back to the Challenger. He would be floating in the cargo bay's box, unable to reach a handhold, just a few yards from safety but separated by an impassable wall of physics. What could the shuttle do in that moment? The Space Shuttle was a massive vehicle. It weighed nearly 200,000 pounds in orbit. It was a truck, not a nimble interceptor. To move the shuttle toward a single person was a delicate, dangerous operation that had never been attempted. The shuttle's own reaction control system, the RCS, used powerful thrusters that burned a hypergolic mixture of hydrazine and nitrogen tetroxide. These thrusters produced a plume of superheated, toxic, and highly corrosive gas. If the pilot of the Challenger tried to fly the ship toward Bruce to catch him, the exhaust from the shuttle's engines could easily melt Bruce's suit or send him spinning into the abyss like a leaf in a hurricane. To save him, they might have to kill him. It was a paradox that the mission controllers had debated for years. And if the MMU thrusters stuck open, if a single solenoid valve failed and began to fire nitrogen continuously, Bruce would enter what they called the death spin. As the rotation speed increased, the centrifugal force would pull the blood out of his brain and toward his feet and hands. He would first experience a gray out, then a total blackout. He would be spinning, unconscious, at several revolutions per second, moving away from the ship at a steady, accelerating rate. Within minutes, he would be a mile away. Within an hour, he would be a ghost, a permanent part of the orbital debris. These were the ghosts that haunted the hallways of the Johnson Space Center. These were the scenarios they had practiced in the simulators until their hands shook. But as Bruce floated at his furthest point, he didn't feel like a victim of these scenarios. He felt like the architect of them. Bruce McCandless was a man who understood the value of patience. He wasn't a man who needed the spotlight or the immediate gratification of the right stuff hotshots. He was a man who needed the data. For him, this flight wasn't about the ego. It wasn't about being the first. It was about proving that the math worked. He had spent thousands of hours in the Neutral Buoyancy Lab, the NBL, in Houston. It is a massive pool, millions of gallons of water, containing a full-scale mock-up of the shuttle's cargo bay. Underwater, wearing a weighted suit that made him neutrally buoyant, Bruce had practiced the MMU flight plan until it was more than memory. It was instinct. He knew the exact click of the joystick. He knew the exact duration of a station-keeping pulse to counteract the subtle drift caused by his own breathing. He knew the way the suit would shift its weight when he moved his center of gravity. In the pool, there were divers just out of frame. There were safety tethers. There was the comfort of knowing that up was only 30 feet away and led to a room filled with air and colleagues. But here, up was 200 miles away, and the water had been replaced by a vacuum that would boil his blood in an instant if a single seam in his suit failed. Bruce checked his gauges on the chest-mounted display. He had to use a small mirror attached to his sleeve to read them, as the helmet prevented him from looking down at his own chest. Nitrogen pressure in the alpha tank, 2,800 psi. Beta tank, 2,800 psi. Battery life, optimal. Oxygen levels, perfect. The machine was holding its breath with him. He decided to do something that wasn't strictly in the formal flight plan, but something that every pilot understands. He decided to test the feel of the deep. He initiated a slow 3-axis rotation, a yaw, a pitch and a roll combined into one elegant movement. The Space Shuttle Challenger began to sink below the horizon of his helmet. Then the Earth began to rise. From this vantage point, the Earth is not a map. It is not a classroom globe. It is a living, breathing, radiant entity. He was passing over the mid-Atlantic. The blue of the ocean was so deep, so intense, it felt like it was vibrating against his retinas. He could see the sun glint off the water, a blinding silvery path that followed the movement of the sun across the waves. He could see the massive thunderstorms over the African coast, tiny white cotton balls of clouds that held lightning stritchki the size of cities. He realized, with a jolt of clarity, that he was the only human in existence who was seeing this without the framing of a window. When you look through a window, you are a spectator. You are looking at a picture, a captured moment. But Bruce was in the picture. There was no glass, no metal, no barrier between his eyes and the curvature of the world. There was only the thin, transparent layer of his polycarbonate visor. He felt a sense of profound cosmic insignificance, but it wasn't a depressing feeling. It was liberating. If he were to fall, he wouldn't fall into a grave. He would fall into that blue. He would become a shooting star, a brief streak of light over the Sahara, a moment of fleeting beauty for a nomad looking up at the night sky. I was very much aware, Bruce would later say in his typical understated engineer's way, that I was a very small part of a very large system. He was the smallest satellite, but he was also the most aware. He was experiencing the overview effect in its most potent, undiluted form. He wasn't just seeing the Earth, he was orbiting it as its peer. He began the journey back. Returning to the ship is, in many ways, more psychologically difficult than leaving it. In space, there is no depth perception. There are no shadows to help you judge distance. Because the light of the sun is so harsh and the shadows are so absolute, there is no atmospheric haze to tell you that an object is far away. The shuttle looked exactly the same size whether he was 200 feet away or 100 feet away. He had to rely on the range rate data. He had to trust the math over his own eyes. He pulsed the thrusters. Forward. The Challenger began to grow in his visor. The white silica tiles of the fuselage became distinct, each one a hand-placed shield against the fires of re-entry. He could see the individual thermal blankets on the cargo bay doors, textured like a winter coat. He could see the reflection of the sun in the cockpit windows, a star trapped in glass. And then he could see the faces. Vance Brand, the commander, Robert Gibson, the pilot, Ronald McNair, and Robert Stewart. They were standing at the windows, their cameras held to their eyes, their expressions hidden by the glare, but their presence felt like a physical warmth. They were witnessing a man returning from the ultimate frontier. Bruce didn't rush. A hot approach was an amateur's mistake. He moved with a glacial, engineering precision, slowing his closure rate as he neared the bay. He brought the MMU into the box of the cargo bay, hovering just inches from the flight support station. He lined up the docking latches, the two metal stings that would lock the chair back into the ship. Click. The mechanical snap vibrated through his suit, a jarring, wonderful sensation. He was no longer a satellite. He was once again an extension of the ship. He was once again bound by the tethers of human construction. He was home, but the mission was far from over. This was only the first flight of the MMU. There were more tests to run, more distances to cover, and more equipment to evaluate. As the sun began to set behind the Earth, a sunset that happened every 90 minutes, a spectacular bruise of purple, orange, and blue that lasted only seconds. Bruce prepared for the next phase, because the MMU wasn't just built for sightseeing. It wasn't built for the sake of a photograph, however iconic that photograph would become. It was built for the catch. NASA had a dream in 1984. They wanted to be able to fly out to a broken satellite, grab it with their hands, and bring it back to the shuttle for repair. It was a vision of a space garage, a way to make the billions of dollars invested in orbital hardware sustainable. They wanted to turn the astronauts into the mechanics of the heavens. But how do you catch a satellite that is spinning? How do you grab a multi-ton object while you are floating in a nitrogen-powered chair? How do you synchronize your heartbeat with a tumbling machine? In the parts to come, we will explore the high-stakes world of satellite retrieval. We will look at the Solar Max mission, the technical ghosts, and hardware failures that almost ended the MMU program before it truly began, and the final, haunting fate of the machine that Bruce McCandless loved. Bruce was back in the bay, his boots once again touching the metal floor, but his mind was still out there, 300 feet away. He had tasted the absolute freedom of the void, and he knew that the world below would never look the same again. He had left as a pilot, but he had returned as a part of the celestial mechanics. Bruce McCandless had proven that a human being could become a satellite. He had shown the world that the umbilical cord of gravity could be cut, and that a man armed with nothing but a throne of nitrogen could navigate the abyss with the precision of a surgeon. But for NASA, the untethered walk was never meant to be just a poetic stroll through the stars. It was a proof of concept for a much more ambitious and much more industrial vision of the future. By the spring of 1984, the Space Shuttle program was entering its golden age of optimism. The engineers in Houston and the politicians in Washington no longer saw the shuttle as just a vehicle for exploration, they saw it as a workplace. They envisioned a future where the Earth's orbit was a bustling construction site, a place where satellites were launched, repaired, and refueled like trucks at a roadside stop. They called it the Space Garage. But to realize this dream, they needed the MMU to be more than a jetpack. They needed it to be a tow truck. They needed a human being to fly out into the void, intercept a multi-ton piece of malfunctioning hardware, and wrestle it into the cargo bay. This brings us to the most dramatic and perhaps the most humbling chapter in the history of the MMU, the mission to save Solar Max. The Solar Maximum mission, or Solar Max, was a sophisticated observatory launched in 1980 to study the sun during its peak activity cycle. It was a billion-dollar eyesore, a massive cylinder covered in gold-colored Captain foil and bristling with sensitive solar instruments. But just months after its launch, the satellite's attitude control system failed. It lost its ability to point itself at the sun. It began to drift, a crippled, billion-dollar ghost, slowly tumbling in the dark. For 4 years, Solar Max orbited in silence, a monument to the fragility of orbital technology. But in April 1984, the Shuttle Challenger, the same ship Bruce had flown just months earlier, returned to orbit for mission STS-41C. This time, the goal wasn't just to fly the MMU, it was to use it for the first ever orbital satellite salvage. The pilot chosen for this high-stakes catch was George "Pinky" Nelson, and while Bruce McCandless watched from the ground, having helped design the very tools Nelson would use, the mission became a masterclass in the unpredictable physics of the void. Imagine the scene through Pinky Nelson's visor. He is strapped into the same MMU that Bruce had made famous. He is 300 feet away from the Challenger. Ahead of him, the Solar Max satellite is looming like a golden tower. It is the size of a school bus, weighing nearly 5,000 pounds. It isn't sitting still. It is slowly, lazily tumbling, a nutational wobble that makes its capture a deadly game of timing. To catch it, Nelson had a specialized tool called the TP-AD, the trunnion pin acquisition device. It was a large, T-shaped frame mounted to the front of the MMU. The plan was simple on paper. Nelson would fly the MMU directly at the satellite, line up the TP-AD with a small metal pin on the satellite's side, and trigger a set of mechanical jaws to clamp down. Once attached, he would use the MMU's thrusters to stop the satellite's spin and fly it back to the shuttle's robotic arm. But in space, simple is a dangerous word. As Nelson approached the satellite, he was fighting a psychological phenomenon known as relative motion. When you are in orbit, your brain struggles to understand that you and your target are both moving at 17,000 miles per hour. You feel like you are standing still and the satellite is a stationary wall. But as you get closer, the perspective shifts. Every tiny pulse of Nelson's thrusters changed his trajectory in ways that felt counterintuitive. If he accelerated toward the satellite, his orbital altitude would increase, and he would actually end up overshooting it in a long, slow arc. To go forward, he often had to point his thrusters in directions that felt wrong. Nelson reached the satellite. He was inches away. He could see the individual wrinkles in the gold foil. He could see the rivets. He could feel the massive presence of the 5,000-pound machine. It felt like a living thing, a silent giant. He lined up the TP-added jaws with the pin. Click. But the jaws didn't close. The TP-add, a masterpiece of engineering, had met a tiny, unforeseen obstacle. A small piece of thermal insulation, a mere sliver of plastic foil, was covering the pin. It was enough to prevent the triggers from engaging. Nelson tried again. He pushed the MMU harder against the satellite, trying to force the jaws to lock. But Newton's third law was waiting for him. Every time he pushed against the Solar Max pushed back. Without a tether to hold him, Nelson was simply bouncing off the satellite like a billiard ball. And then the nightmare scenario happened. In his frustration, Nelson tried to grab a solar array with his gloved hand to steady himself. This was an instinctive human move, but in the vacuum it was a catastrophe. The force of his touch was transferred into the tumbling satellite. Instead of steadying it, he gave it more energy. The Solar Max began to spin faster. The slow, lazy wobble turned into a violent, chaotic tumble. "I've got a problem here," Nelson radioed, his voice tight. Inside the Challenger, the crew watched in horror. The satellite was now a 5,000-pound centrifuge. Nelson was being tossed around like a doll. His nitrogen supply was dwindling. The MMU thrusters were firing continuously as the automatic stabilization system fought to keep him from spinning out of control. This is the moment where the space garage dream met the reality of the frontier. We had built a machine, the MMU, that was perfect in the controlled environment of an empty bay. But we were trying to use it to master a world that we didn't yet fully understand. Nelson had to retreat. He flew the MMU back to the Challenger. Exhausted, his forearms cramped from fighting the suit, his pride stung. The mission was on the verge of a billion-dollar failure. The Solar Max was now spinning so wildly that the shuttle's robotic arm, the Canadarm, couldn't reach it. The satellite's solar panels were no longer pointing at the sun, meaning its batteries were dying. Within hours, the satellite would freeze and become a permanent piece of space junk. Bruce McCandless, watching the data from the ground, felt the weight of the failure. He had spent his life advocating for the MMU, for the freedom of the untethered astronaut, and now the world was seeing that freedom as a liability. But the story of the MMU is also a story of human grit. The crew of the Challenger didn't give up. They spent the next 48 hours in a frantic orbital chess match. From the ground, controllers sent a series of desperate commands to the satellite's dying computer, trying to use its internal magnetic field, a magnetic brake, to slow the spin. It worked. Just barely. The spin slowed enough for the Challenger's commander, Robert Crippen, to perform a daring piece of piloting. He flew the massive shuttle itself, a vehicle the size of a DC-9 airplane, within inches of the tumbling satellite. The shuttle's robotic arm operator, Terry Hart, waited for the perfect moment, the one-shot opportunity, and snatched the Solar Max out of the void. They brought it into the bay. They fixed it. They replaced the faulty modules using the very tools Bruce had designed. They relaunched it, and the Solar Max continued to study the sun for another 5 years. It was a triumph, but for the MMU, it was the beginning of the end. The Solar Max mission showed that while the MMU was a brilliant piece of technology, it was also a specialized tool for a very specific type of work. It was expensive. It was heavy. It took up a massive amount of space in the cargo bay. And most importantly, the mission showed that the space shuttle itself, piloted by a skilled commander, was often a better maneuvering unit than a single astronaut in a jetpack. The space garage didn't need a man in a nitrogen chair. It needed a robotic arm and a very good pilot. After the Solar Max mission, the MMU flew only one more time on mission STS-51A in November 1984. That mission was the double catch. Astronauts Dale Gardner and Joe Allen used the MMU to capture two stranded communications satellites, the Palapa B2 and the Wester 6. The images from that mission are even more surreal than Bruce's first walk. They show Joe Allen, a small man, literally holding a massive 1,000-pound satellite over his head like Atlas, while Gardner uses the MMU to push them both toward the cargo bay. They were the ultimate space mechanics. They even took a photo holding a sign that said "For Sale," a cheeky nod to the insurance companies that had paid for the salvage. It was the peak of the program. The MMU had finally done what it was built to do. It had retrieved the hardware of the heavens. But as Gardner and Allen stepped back into the Challenger, the political and technical winds were shifting. NASA was beginning to realize that the risk-to-reward ratio of the untethered walk was becoming harder to justify. Each MMU flight required dozens of safety waivers. The suit itself was nearing its limits. The internal cooling systems, the joints, the gloves, everything was being pushed to the breaking point, and there was a ghost in the machine. During the post-flight inspections of the MMUs used in 1984, engineers found something disturbing. They found tiny, microscopic leaks in the nitrogen valves. They found that the electronic brains of the units were vulnerable to the intense electromagnetic interference from the shuttle's own radar. The MMU was a Ferrari in an environment that demanded a Caterpillar tractor. It was too delicate for the long-term industrial work of the space station era. Bruce McCandless watched as his smallest satellite was gradually sidelined. NASA began to focus on tethers again. They developed the SAFER system, the Simplified Aid for EVA Rescue. It was a tiny, emergency-only version of the MMU, designed to be worn like a parachute. It wouldn't let you fly like a bird. It would only help you crawl back to the ship if you fell. The era of the untethered cowboy was coming to a close, but there was a deeper shadow falling over the program. A shadow that would change NASA forever. 1984 was a year of the catch, but 1986 was the year of the fall. The Space Shuttle Challenger, the ship that had been Bruce's home, the ship that had carried the MMU into history, was destroyed 73 seconds after launch in January 1986. 7 of Bruce's friends and colleagues were lost. In the wake of the Challenger tragedy, NASA entered a period of profound soul-searching. The optimism of the space garage evaporated. The space truck was grounded. Every single piece of hardware was re-evaluated through the lens of extreme risk. The MMU did not survive the audit. It was deemed too risky. The lost astronaut scenario, once a manageable calculated risk, was now an unthinkable political liability. NASA could not afford to lose another person, especially not in a way that would be broadcast live to a world already reeling from the Challenger explosion. The MMUs, the thrones of nitrogen, the machines that allowed us to be peer to the planets, were retired. They were packed into crates. They were sent to museums. But Bruce McCandless didn't disappear with his machine. He remained at NASA, a quiet sentinel of the engineering dream. He continued to work on the Hubble Space Telescope. He continued to advocate for the human touch in the void. He knew something that the politicians and the risk assessors had forgotten. He knew the feeling of the 1500 character Part 2. He knew that to truly understand our place in the universe, we cannot just look through a window. We cannot just reach out with a robotic arm. We have to go out there. We have to feel the silence. We have to be the smallest satellite. If you were to walk into a quiet gift shop in the heart of London, a bustling science classroom in Tokyo, or a child's sun-drenched bedroom in a small, sleepy town in the middle of Iowa, you would likely find him. He is there, an omnipresent specter of our greatest ambitions. He is on the glossy front of postcards, on the covers of heavy science textbooks, on posters pinned to the walls of dreamers who look at the ceiling and see the stars. He is a white geometric silhouette set against a velvet black abyss, floating with an impossible, terrifying grace over the crystalline sapphire curve of a blue and white world. He has no face. His visor is a flawless gold mirror, reflecting only the vastness of the universe back at itself. He has no name to the millions of people who have stared at that image in a state of paralyzed awe. To the world, he is not a man. He is the astronaut. He has become the ultimate universal symbol of human potential, the icon of what it means to be a species that refuses to stay on the ground, a species that dares to step off the edge of the world and into the infinite. But behind that gold mirror was a man named Bruce McCandless II, and as the nitrogen tanks of the manned maneuvering unit were eventually drained for the very last time, and as the program that had been his life's singular work was shelved in the name of bureaucratic safety and the crushing weight of tragedy, Bruce had to learn a different kind of courage. He had to learn how to live in a world where he would forever be remembered as a tiny, distant, and lonely speck, while the man himself remained quietly, humbly in the shadows of the very history he had helped to write. To truly understand the final chapter of this journey, we must look at the long, heavy silence that followed the triumphant roar of 1984. The Space Shuttle Challenger, the vessel that had served as Bruce's mechanical island in the black, the ship that had given him his throne of nitrogen, was destroyed on a cold, bright January morning in 1986. Bruce wasn't on that flight, but the 7 people who were Dick Scobie, Michael Smith, Judith Resnick, Ellison Onizuka, Ronald McNair, Gregory Jarvis, and Krista McAuliffe were his family. They were the people he had trained with, joked with, and shared the silent, pressurized anxiety of the pre-flight checklists with. Ronald McNair, in particular, had been in the cargo bay with Bruce during that first untethered walk. They had shared the same recycled air, They had marveled at the same lightning-torn African thunderstorms from the windows of the cockpit. When the Challenger vanished into a jagged white cloud over the Atlantic, the very soul of NASA was fractured. The can-do optimism of the early shuttle era, the belief that we were building a space garage where anything could be repaired and anyone could fly, was replaced in a heartbeat by a grim, heavy, and paralyzing realism. The MMU, the nitrogen chair that Bruce had championed for decades, was one of the first casualties of this new era of caution. The safety boards and the risk assessment committees looked at the MMU and they didn't see a miracle of human freedom. They saw a massive, unacceptable liability. They saw a lost astronaut scenario waiting to happen in the cold, unforgiving glare of a live television broadcast. They saw a machine that was too bold, too poetic, and too independent for a world that had suddenly become very, very afraid of the dark. Bruce watched as the MMU was retired from service. He didn't protest with loud, self-serving speeches or angry editorials in the newspapers. That simply wasn't his way. He was a naval officer and an engineer, a man raised on the principles of duty and the cold logic of the data. He accepted the findings. He understood that in the wake of such a public tragedy, the collective appetite for risk had completely disappeared. But in his heart, in the quiet places of his mind where he still felt the hiss of the nitrogen jets, he knew that the tether we were reattaching to our astronauts was more than just a steel and nylon cable. It was a psychological leash. We were deciding as a species that the void was a place to visit with extreme caution, not a place to inhabit with the freedom of a bird. We were choosing to be spectators once again rather than participants. Bruce spent the rest of his career at NASA doing what he had always done best, making the impossible functional. He moved from the kinetic dreams of the MMU to the optical dreams of the Hubble Space Telescope. If the MMU was his dream of personal, untethered flight, Hubble was his dream of universal, unclouded vision. Bruce was a key player in designing the specialized tools and the intricate extravehicular activity EVA procedures for the Hubble deployment and the subsequent legendary repair missions. He was the man who figured out how a person encased in a stiff, pressurized glove could turn a tiny, delicate screw on a telescope that was designed to look back through the billions of years to the very beginning of time. He was the bridge between the clumsy human hand and the divine cosmic eye. When the Hubble was finally launched in 1990, Bruce was there in the control room, his face illuminated by the glow of the monitors. He watched as the telescope he helped build began to send back the first images of distant nebulae, of colliding galaxies, of the pillars of creation rising like ghosts in the Eagle Nebula. He realized then that while he had once been the smallest satellite, he was now helping the entire human race see the furthest horizons. He had traded his own personal flight for the collective vision of billions. He had found a way to be useful even when his throne had been taken away. But as the years turned into decades, the image of Bruce in 1984 grew in its cultural and spiritual power, even as the man himself aged in quiet suburban dignity. He was often asked by journalists, by students, and by fans what it actually felt like to be out there, alone in the deep. People expected him to talk about the gut-wrenching terror, about the adrenaline-pumping heroics, about the right stuff, swagger, but Bruce always spoke with the calm, measured tone of an engineer who had found a beautiful, elegant solution to a difficult mathematical problem. It was a wonderful feeling, he would say with that slight, characteristic grin. A sense of professional accomplishment. I had worked on the system for so many years and it finally worked exactly as it was supposed to. He was perhaps the only person on the planet who could look at the most terrifyingly beautiful photograph in human history and see primarily a successful technical demonstration. In his later years, Bruce would occasionally visit the National Air and Space Museum's Udvar Hazy Center in Virginia. It is a massive cathedral-like building where the giants of aviation go to rest. There, hanging in the sterile, quiet, and climate-controlled air of the hangar, is the MMU. It is a hollow shell now. Its nitrogen tanks are empty, their pressure long since bled away into the atmosphere. Its electronics are dead, their circuits silent. It is a relic of a future that arrived for a brief moment and then quietly departed. Visitors walk past it in their thousands, barely noticing the white backpack on its stand, and then they stop at the giant, wall-sized photograph of Bruce floating in the black that hangs nearby. They look at the photo, and then they look at the machine, and they struggle to connect the two. In the photo, the MMU looks like a chariot of the gods, a vehicle of infinite liberation. In the museum, it looks like a piece of heavy industrial equipment, a strange chair for a ghost. Bruce would stand there, a quiet, white-haired man in a simple windbreaker, watching the tourists. He rarely, if ever, told them who he was. He didn't need the recognition. He didn't need the fame. He was content to know that the machine had done exactly what he had asked it to do. He was content to know that for 90 glorious silent minutes, he had been the master of the vacuum. He had been the one who had finally cut the cord. But there is a profound, lingering poignancy to that retirement. Every time a modern astronaut steps out of the hatch of the International Space Station today, they are tethered. They are connected by steel cables and nylon lines. They move with extreme practiced caution, always keeping at least one hand on a yellow handrail, always acutely aware of the line that connects them to the station. They wear a small, compact unit called EFA on their backs, a tiny, emergency-only version of Bruce's MMU. It is there just in case they fall, a life jacket of nitrogen that they hope and pray they never have to use. We have returned to being kites. We have returned to being divers on an umbilical cord. The dream of the untethered cowboy, the person who flies through the deep like a bird of the vacuum, remains a frozen, beautiful moment in 1984. Bruce McCandless II passed away on December 21, 2017, at the age of 80. When the news of his death reached the world, that 1984 photograph was everywhere once again. It was on the front pages of every major newspaper, from New York to London to Sydney. It was trending on every screen, a silent tribute in pixels. And for the very first time, many people actually took the time to learn his name. They learnt about the man behind the gold visor. They learnt about the brilliant engineer who had stayed behind in the shadows so that others like Neil Armstrong could go to the moon. They learned about the voice that had guided the Apollo 11 crew through their most dangerous moments. They learned about the person who had spent 20 long years of his life perfecting a chair so that he could, for 1 hour, sit in the absolute silence of the universe. But as the world mourned the man, the image remained. It remained as a challenge to us. We are currently entering a new, bold age of spaceflight. We are talking once again about returning to the moon with the Artemis missions. We are talking about the Gateway Station. We are talking about the cold red dust of Mars. We are moving back into the deep further than we have ever gone before. And as we prepare for those immense journeys, we have to decide as a species what kind of explorers we truly want to be. Do we want to be the cautious, tethered visitors, forever tied to our machines, forever afraid of the lost astronaut scenario? Or do we want to be the children of the stars that Bruce McCandless showed us we could be? Bruce's journey was what we might call the longest inch. It was the distance between the safety of the ship and the discovery of the self. He showed us that the ultimate freedom isn't found in the raw power of a rocket engine, but in the quiet, steady courage to let go of the line. He was a man who understood that the universe is not a hostile, alien place to be conquered or feared. It is a place to be inhabited. It is a place where we belong, if only we have the nerve to step out into it. Imagine him one last time. This is the moment that defines the human spirit. The year is 1984. The ambient music in your ears should be a steady crystalline pulse, a vibration of pure, cold light. Bruce McCandless is 320 feet away from the Challenger. He has just completed his final maneuvering test. He has spun, he has rolled, and he has looked deep into the amber twilight of the Earth. He knows he has to go back soon. He knows his nitrogen pressure is beginning to drop. He knows that the world of gravity, of committees, of oxygen masks, and of ground-level stress is waiting for him just a few hundred feet away. But for just one more minute he stays there. He refuses to move. He stops the thrusters. He stops the rhythmic movement of his hands on the joysticks. He becomes perfectly, unnervingly still. In this specific moment, Bruce McCandless is the most isolated human being in the entire history of the species. He is more alone than the furthest desert hermit, more solitary than the deepest mountain monk. He is a single, fragile point of human consciousness suspended in a billion miles of cold, dark nothingness. But as he floats there, he doesn't feel lonely, not for a single second. He feels the warmth of the sun on his back, a radiant heat that has traveled 93 million miles through the void just to touch the white fabric of his suit. He feels the invisible, tectonic pull of the earth beneath him, a silent, ghostly hand of gravity that keeps him from drifting away into the galactic dark. He feels the soft, humid human of his own breath, a rhythmic, mechanical proof of his own persistent existence. He looks at the stars. They don't twinkle here. They don't flicker or fade. They are hard, steady, brilliant points of light, like millions of diamonds pressed into the surface of black velvet. He looks at the Milky Way, a vast, spiraling river of silver and dust that stretches across the entirety of his gold-tinted vision. He realizes in this moment that the tether was never a cable of steel. The tether was his own fear, and now that it is finally gone, he is finally truly connected to everything. He isn't a man in a suit anymore. He is a part of the orbital mechanics. He is a part of the rotation of the planets. He is a part of the ancient, slow, and majestic dance of the cosmos. He is the smallest satellite, but he is also the greatest explorer we have ever had, because he didn't go to find a new world or to plant a flag of conquest. He went to find a new way to be human. He went to show us that we are not prisoners of the Earth. The photo will live forever. Long after the space shuttle is a footnote in the digital history books, long after the Challenger is a distant, half-forgotten memory, that image of the white silhouette against the black will remain. It will remain as a constant, silent reminder that we once reached out and touched the infinite, that we once had the collective courage to let go of the line. Bruce McCandless II may have come back to Earth. He may have lived a quiet, honorable life of engineering and service. He may have been buried in the ground of the world he once orbited as a moon. But a part of him, the best part of him, never actually came back. A part of him is still out there, drifting in the silence. If you look up at the night sky tonight, far away from the blinding lights of the city, and if you wait until your eyes adjust and the satellites begin their silent, steady trek across the stars, you might see a tiny, moving point of light. It's moving fast, 17,000 miles per hour, tracing a lonely path over the oceans and the mountains of our home. It's just a piece of metal, a hunk of modern technology, a satellite doing its job. But in your mind, in the quiet theater of your imagination, you can see it differently. You can see the white chair. You can see the gold visor. You can see the man who decided that the only way to truly see the world was to leave it entirely behind. Bruce McCandless is still flying. He is still the master of the loneliest walk. He is still showing us the way to the eternal horizon. He is telling us that the dark isn't something to be feared, but a place to find ourselves. The ambient music fades now into a single, high-pitched, crystalline note. It is the sound of a star. It is the sound of a vacuum. It is the sound of absolute, unburdened peace. Because when you are finally untethered, you aren't lost in the dark. You are finally, truly found. Good night, Bruce. And thank you for the leap. Thank you for showing us that the sky isn't a ceiling, but a floor. The mission is complete.